All right.
Let's say from the lab.
So,
FD cosine theta?
yeah, just to recap, I don't like FD, man, because like displacement is delta x. But if you look online, like if you ever look on like Minute Physics or the Physics Classroom or Hyperphysics or whatever, if you ever look for online resources, 99 times out of 100 it'll be written as FD cosine theta, so whatever.
Physics also needs some website editing. It's such a bad website.
Yeah, it's ugly. It is ugly. But they have some great resources.
No, yeah.
They got some great resources. So this was the algebraic workaround that we got from this guy right here. And it works out pretty well when we're given like a magnitude and a direction for a vector. If we're given the vector in the force or the displacement in vector notation, like with the components already given to us, then we're better off computing the dot product with the integral. Like it really is much better for us, or at least much easier for us, because it's just such an easy thing to do. Granted, this works when the force is constant. We're going to see a case in a second when the force is not constant. I did stress that that angle, phi, you'll never see it as phi. Like it's written as FD cosine theta. But the reason why I wrote it as phi is because we've been using the word theta, or the angle theta, specifically to refer to the angle that defines the direction of the vector. Like that is the angle that starts from an axis and then goes to where the vector is. That to me, that's what I always think of when I think of theta. That's not what this angle refers to. It's always the angle between the two vectors, and that's why I changed it to something different. And that looks a whole lot like that. So we're going to have a little bit of geometry sometimes to try to figure out what that angle is. Although to be fair, really often physics gets really lazy, and phi and theta tend to be the same thing. I have a displacement on an axis and a force not on an axis, and that makes life really easy. That phi theta, though, that cosine phi, though, has, in the algebraic world, you don't have to write down most of this because we're not going to live with most of this, but I want you to kind of process it and think about it. It has some consequences. It does a lot of the heavy lifting for the algebra equation that the dot product kind of just does naturally. The dot product automatically, as it goes through, takes care of signs, right? Whether the work is going to be positive or negative. It also takes care of whether there's going to be any work at all. If I did not have the cosine phi part, I would never get signs. I would never get an option of getting zero work. This guy tells me when I'm going to have zero work. For example, when my force and my displacement are, where's my word? I know, but I saw it, but now I can't find it. Oh, there it is. Orthogonal. Yeah, I can find it. Sorry, I'm not here. I've already had 6 cups of coffee in my heart. In my heart. I've only had 2 in my stomach, but in my heart I've drank 6. I've only drank 2 cups of coffee. I want more, but I haven't had a chance. I literally just watched Bright last night. I don't know if any of you guys have watched it. There's that scene where she pulls out the thing from her skin. That's what I want to do with coffee right now. Just pull out like a Starbucks out of my forearm. So when I have my vectors that are orthogonal to each other, they don't share components. Perpendicular. Math, for some reason. Could you tell me why there's 3 words? Normal, orthogonal, and perpendicular? And then if you ever take linear algebra, which is a great class, I legitimately really enjoyed that class. I had a lot of fun in it. But if you ever have the pleasure and the honor of taking that class with Teddy Dragic from FIU, he will use the words orthonormal so often. I don't know what it means. I have no idea what.
Is that an actual word?
Yeah, orthonormal is something. Orthonormal is something. He's like, in order. It's 90 degrees in bold. I don't know, man, but yeah, they all mean the same thing.
Last time we were talking about how phi is the empty set, the golden ratio, and now the angle between vectors.
Yeah, you could change it to whatever you want, whatever angle you want. I only used phi because it's the only other angle that I like. Like it's the only other angle variable that is nice. I don't like alpha because that's an acceleration. I don't like omega because that's a velocity. It's also a resistance. Omega, lowercase omega is the W, and then uppercase omega is resistance. Ohms, yeah, ohms. So there's no other one that I like a lot. I also don't know what this one is. I don't know what this letter is. I don't know what that letter is. I know it's a Greek letter. I know that it's in nuclear and particle physics because Boglin in my physics class did that, and he called it squiggle. Squiggle.
Look at it. It's a face piece of magic.
I don't know what the heck it is, but that's another one.
It's a nose and a mouth.
Do you think it's a Greek letter? I'm gonna look at it.
Yeah, he told us it was a Greek letter. I don't remember what the Greek letter is, but he called it squiggle, and it's related to the solid angle of something. I don't remember.
Why don't you use Hebrew letters?
Because I don't know those. I don't know those.
Wait, he called it squiggle?
Yeah, he called it squiggle. He's like, it's got a name, but I don't like it, so I'm gonna call it squiggle. And I was like, all right, man, cool. I don't know anything that's going on in this class, anyways.
We call it fishy in here.
Yeah. Lowercase alpha looks like a fish. Yeah. I hate when people call it fish, man. It's like if I started calling you by not your name.
I don't think he gets offended.
I get offended for it. It's 2018, okay? So I'm not really too worried about the consequences of the cosine phi, except when we do live in the algebra. Chi. All right. Haha. So squiggle. Yeah.
And the uppercase version is not much better. It's freaking weird.
Yep. Go. So when we live in the algebra world and we're computing works with FD cosine phi, what's going to be really important are the values of phi, because that could give us positive or negative values. And we're allowed to have positive or negative values for work, because a positive value means that my system is gaining energy, gaining work, and a negative value means my system is losing energy or losing work. We know that cosine, all students take calculus.
No. False. You need to use the top, right?
Wait, what?
No.
No what?
Cosine is positive in these two regions.
Yes, don't ever say that to them.
No?
No.
All right, whatever. Either way, cosine is positive in the first two regions.
Wait,
What?
No, we knew it was
I missed it. What are we?
It doesn't matter. It's
positive and negative.
Okay,
No,
cosine
it's
is
about the-
X, so
Right.
Yeah.
Cosine is positive on that side.
Yeah.
Sine is positive on that side.
yeah.
Like related to X and Y, that little
What's so bad about
Is it
this?
little-
It's a mnemonic that's not great, but whatever.
No, it's just because when the problems get more complicated, that fails and people rely on it.
Oh,
So
great.
so I don't. Sorry. I didn't
I've only ever used it for the X. I've only ever used it for literally like this. That's the only time that it's
No,
valuable
I know, but
for
they
me.
don't know
But
what that is, and I purposely kept them from it. I sheltering them
so
from corruption.
for all that matters for us, cosine is positive in the first quadrant and in the fourth quadrant, right? The X stuff, cosine is usually related to the X component, is positive in first and fourth, and negative in second and third. So when I've got angles that are here, then my work is going to end up being positive. If I've got angles that are here, my work is going to end up being negative. A very, very simple example would look something like this. What's this box doing? Forget the force for a second. What's this box doing? Moving to the right, right? Now, if I have that force, it is, it could be, but I don't care. Big picture. What's the box doing?
The resisting force. Well, it's
The box
oh,
is
it's decelerating.
Slowing down. The box is slowing down. That force is causing this box to slow down. Does that make sense? Now, a very common misconception is that the force needs to cause the displacement. No, it just needs to change the displacement. That's what it's got to do, right? And this force is changing the displacement. Without this force, it would just keep displacing in the same way like it always is. With this force, the way that it's displacing is going to start to change. It's going to slow down. This system is going to lose energy. But what else is it also losing? No. If it's slowing down, it's losing Velocity or speed. I'll take either one.
Wait, so who's gaining energy and who's losing energy?
It could be going somewhere else. It depends on what this force is.
Like, okay, let's say I'm pulling the box. So I'm gaining energy by.
You could be gaining energy. Could be. Very often, maybe you could use this to power like a winch or a pulley or something to lift something else up. Or if this is something like friction, and this is why we said that work comes from mechanical methods of pushings and pullings and heat. If this comes from something like friction, take your hands real quick for a second and rub them together, and you'll notice real quickly that they get hot. What friction always does is creates heat. Friction, that force of friction, always turns in that energy into heat.
Isn't
Always.
breathing? Like it's not thermal energy like the hardest one to.
Yeah. The trickiness is, and I think I might have said it, I'm going to come back to this in a second. Yeah, I did say it in a little bit. To be fair, most other kinds of energy that aren't potential are kinetic. So heat is actually kinetic energy. That's really what it is. But
Thermal energy is what a kinetic energy.
thermal, so this is where you got to be a little bit careful. Thermal energy is a really big umbrella term that is all types of internal energies. Heat, in terms of raising temperatures, is kinetic energy. Because what heat is the particle motion, the how quickly or slowly particles are moving inside of a gas or a liquid or a solid or whatever. The faster those things move, the more energy they have, the more heat they have. Yeah? Or the more temperature they have. What's up, Gabby?
Why did you say it's not losing energy?
It's losing energy. The work done here is negative. That means that the work is taking away the energy. We're going to need a little bit more tools because it had something. It was moving, right? It had something, and that force is taking that something away. It's slowing the system down, right? And if work is a description of an ability to change, given enough time, that force is going to get this system to do what?
I'm really not understanding if you have two pool balls that bump into each other, right? Let's say they stop or whatever, they bounce.
As soon as
where
you have
does all
things,
the energy
as
go?
soon as you have things hit, then we need to introduce momentum.
But where's energy? Yeah, I get its momentum, but where's energy even going? Disappear.
Let's wait for momentum.
All right.
It'll make a lot more sense when we go through that.
I see why.
Yeah. So what will the system do given enough time? Stop. Right? It'll come to rest. And then ultimately, changing of something that's at rest is what?
No kinetic.
It has nothing. Let's not use kinetic energy yet. But if I'm at rest, am I changing?
No.
Could I change if I'm at rest? Am I?
Like,
Big picture,
okay, no.
big picture. But I'm not. If I'm at rest and I'm just kind of chilling there, sitting on the floor, not doing anything, then I'm not changing. I haven't changed. I won't change unless something else comes by and gives me something to change. So I'm sitting at a big fat zero, right? Now we know big picture as a whole, energy actually can't be negative as a whole. So the number in the universe, the total number in the universe is actually a positive number, right? Because the universe doesn't owe anybody energy. Because where would that energy go to? If the energy was negative, if the universe had a total number, we said originally, the very first thing we said was that the total number of energy in the universe, it has a number. The number exists. The number is not infinite, right? It's a very definite number. It's a very physical, real number, and it has to be conserved. That number always stays the same, right? If that number is positive, it means that energy is, the universe has that energy, and it has the ability to change. And this is one way that it could expand. If it has positive energy, it could use that energy to change in good ways. It could use that energy to get bigger or faster or whatever. But if that number is negative, then it owes that energy to somebody, right? Then the universe lost that energy to somebody else. What else is there outside of the universe? And we don't know. So the assumption is that the number in the universe is always positive, and it's the same number, always the same number.
Yeah.
That is conservation. Yeah, I'm sitting because it turns out that when it rains, broken bones suck. I mean, I already knew that, but I thought it was just surgery. But yeah, suck.
What's the correlation?
When you do, when like,
Arthritis.
yeah, a big part. Yeah, it's barometric pressure is a big part of it. I think. I don't know what else it is. That's the only thing that makes sense to me. But when I broke my leg, my surgeon was like, "Yeah, it's gonna suck in the cold and it's gonna suck in the rain," and I was like, "Nah, yeah, it does. Surprisingly, it does. I really didn't think it would."
You just feel like.
But
At least you live here.
no, I'm dying to go back in the cold. I really am. I love winter. I love winter. I don't want this to stop me
You
from
can go
winter.
skating if you right now.
Yeah, I could.
No, but I mean, like, without dying.
Yeah, I could. Like, I don't think I'm gonna die. Like at this.
They're still teenage bodies, so nothing hurts. Like,
Yeah, I guess. I remember that. Man. When I was a teenager, I could put myself in the craziest, like I did some silly things when I was a teenager, came out unscathed. Everything was cool. I literally jumped 3 inches the day before I turned 27, and I snapped my leg in half. Like, it just blows my mind, man. It's the beginning of the end, man.
Yesterday I was standing in the kitchen and all of a sudden a bone inside my foot, like not my ankle, not something that moves, like something inside my foot just decided to go. It just started hurting. I'm like, I didn't do anything. I did not move. Why?
That's what you have to look forward to, guys.
Yeah.
This is what you have to look forward to. Your body slowly betraying you.
Just fall apart.
Your body slowly betraying you. Nope, life isn't happy, man. So, this would be a case of positive work. I mean, we're getting the pattern. I'm not going to stress too much about it. But we know that in this case, this system is going to speed up. It's going to speed up. So this guy's actually going to, gain energy and gain speed. I do want to stress that it's not only like this one-dimensional stuff, right? Like it's not just moving to the right, going to the right, left, right, 1D. Yeah, everybody does. It could be any relationship as long as the components are either in the same direction or in opposite directions. Does that make sense? Like the angle between these two is 180, and the angle between these two is 0, and that is not the only 2 cases that exist. I could have positive work anytime the angle is in here, and I could have negative work anytime the angle is in here.
How would the speed increase though?
How would speed increase?
Decrease with increase.
Here?
Is that would be impossible, no? To increase energy and decrease speed?
That would be predominantly, in this type of situation, yeah, that would be predominantly difficult to do. There are certain situations where you can do that, and we will never actually see them because they're in electricity. But if I had 2 particles, let's say 2 negative particles or whatever, and I brought these 2 negative particles closer together, we know likes don't like to be near each other, so their energy is actually going to increase, but their speeds will decrease as they come close together. That's one example. Yeah. I don't understand why. I don't understand why Physics 1 sees circuits. It makes no sense. Actually, I know why they do it. It's because of Texas, but whatever. So, yes, because Texas mandates that any full year physics class has to see some type of electricity.
I haven't seen it yet.
Period.
So that's why
love
Physics
Texas.
8 does do it?
Yep. What's up?
Does,
And actually, this is not considered a full year class.
does all? It's not.
Like not officially. Like it's usually a semester class, but most schools just do it the full year.
What?
Physics, AP Physics C Mechanics is not a full year class, not officially.
It used to be
Wait,
one
so question. Does all like work have equal and opposite work and opposite? Like, so by you pushing the chair doing positive work, doesn't the chair has a normal force on you and a negative and an opposite displacement? So that
You're still moving.
means it's doing negative work on you, but you.
Well, if I think about it this way, if object A gives work to object B,
Yeah.
that means that object B took away work from
Or
object
in
A.
other words, it gave negative work.
Sure.
Which is the same thing as
Same thing. So if I give positive work to the chair, it's the same thing as the chair taking work from me.
Yeah.
Means the same thing, right?
Right, okay, right.
If the angle is 180 and the displacement is to the left,
Then that means the force has to go to the right.
and the force goes to the right, is that positive way?
The angle is 180. Cosine of 180 is negative 1.
Right, but
Remember that in this formula, in f delta x cosine phi, the vector parts, those are magnitudes. So they're always positive.
okay.
These two pieces here are always magnitudes. They're always going to be positive numbers. What's going to take care of the sign is going to be the cosine phi piece. That's the thing that's going to tell us the sign.
Okay.
So let's see some ranking tasks. Tippers. I've got 6 scenarios, and in all 6 of these scenarios, the box is identical. Same mass, same surface, same shape, same everything. In all 6 scenarios, I'm applying the same magnitude force. I'm applying it in different ways, but I'm applying the same magnitude force. In the 6 scenarios, they're going to have different displacements. Does that make sense?
Is this displacement, like this displacement already occurred?
This is displacement that is, it doesn't matter. Occurring, already occurred. We're going to rank it anyways based on which one of these scenarios has the most work done to the least work done.
Oh, B is the most.
Now,
Right.
we will rank this based on the magnitude of the most work done. Right? Because negative work done is still work done. Right?
Oh.
The least amount of work done is not doing any work. Does that make sense? Right? So, let's go through this guy. Let's just remember, do I really want to go through like the calculus definition of finding work for this? Is that going to be really helpful? Not really. Mostly because, they gave me such easy vectors for this. All of these have 1D displacements. They're all being displaced either, which way? Right? Like, actually that's not true. All of them are being displaced right. All of them are being displaced right. So I'm going to go ahead and draw.
No, it can't. It's just another force. But the work done by that force then is 0.
Wait, why are you writing delta?
I'm drawing the delta x vector.
Not that it's 0. Work is
That's what I meant. I think it was the last.
Just to make life easy. Just drawing the delta x vector.
F has 0 effect on it.
No, I'm saying it's F. Like,
Oh,
I
oh,
skipped the letter.
oh, I got you.
That's why I said F is 0.
Okay, so there's our formula.
What if there's a tie? How do you win?
You can put equal. Like you could literally just write 3 equals 4.
Oh,
It doesn't matter. But, okay, so there's our formula for work up on the top. All of them have the same f. We can solve this in terms of variables, right? We don't need to give f a number. It's okay. So here A is going to have what work? Positive work, because the force vector and the delta x vector, the angle is 0.
What do you, oh.
The angle between the two is 0. Something that points to the right has an angle of 0, or 360, or 0,
which is 1.
and 2 pi. Doesn't matter. I don't know what it is in gradients. What's 360 degrees in gradients?
Pi.
In gradients?
Oh.
Yeah, it's the same thing. What's the difference between gradients and radians?
Oh,
Radian.
gradient.
Yeah.
But he said radiant.
No. Radians is 2 pi. But what is it in? I love how you were all looking at me like, you idiot. No. Yeah, I know, guys. I don't need that much coffee. Like,
What are
He's not even, he just can't talk.
gradients. Yeah, my throat at this point is already pretty dead. I'm sorry.
Add gravity. No,
Oh.
No. I hate myself. I just finished reading a book about radiance, actually. So the angle here is 0. So the work done,
It's 5 on that gradient.
5f.
It's 400
Okay.
gradients. Got it.
How about 400?
400 gradients is 360.
Okay.
Wait, what's the gradient?
I don't know. You have your computer. You have your
Wait, so you actually
supercomputer.
My grandmother says both.
Yeah, I wanted to know what it is in gradients.
Oh,
I don't know.
It is a gradient.
A gradient is another unit. Yeah, she's got it. So what about B? What's the work done in B? It's also still positive because the angle between these two is 0, and it's 10F. Okay. How about C?
Cosine 45.
So 5F is not
Wait, no one ever said it's 45.
because you're finding
Yeah, no one said it's 45, but here's the important part.
5SX cosine. Oh, okay.
Now, here's the important part. It's gotta be, number one, bigger than 0. It's gotta be, right? Because when would that be 0? When would that be 0? Well, I'm not going to say less than 90, actually. No.
No, when it's greater.
No, with the displacement.
what are you
vector-
talking about?
When would the work be 0?
When
Oh,
it's
when
straight
it's
up.
perpendicular.
When the angle is straight
I
up,
thought you were saying
right?
when
But
would
the angle's
angle
not.
be 0. I got it.
So the work has to be greater than 0
Right.
because it's not close to 90.
It has to be less than 5F.
Between 0 and 1.
But it has to be less than 5F because cosine bounces between positive and negative, 0 and 1, right? So that will be my work. That's actually not a bad answer. I'm mostly cool with that. Okay. How about D? 0. Because the angle between these two is 90. Cosine of 90 is 0. How about E?
How do you know it's straight up?
It's going to be negative 5F.
It's the same
Ask
thing.
David. David's in touch.
Take it easy.
Negative 5F, the work done. And another one of... Well, when I rank them, I just want... Here I'm just looking at the work done. I just want to know. So the most amount is... Okay, B.
How are we supposed to know that my work done is not like negative 5, but like E wouldn't be the lowest?
Because I'm still doing work. I'm just taking away the energy.
But then like
Doing work means changing, right?
Yeah.
Doing the least amount of work means doing the least amount of change. So doing no change is definitely less.
So, yeah.
Right?
The negative just in this case is a direct level of...
Well, it's just saying that I'm taking away the energy.
So
Okay.
it's not a direction.
I didn't, yeah.
Yeah, it's not a direction. So what would be the next biggest?
A and E.
A and E. Okay.
Wait, why E? What?
E is okay.
Well, E is still 5F of work. It just happens that I'm taking it away. Okay.
And then C, and then F and D are equal.
So
Oh, FD. Yeah, I like FD better than DF.
It appears that gradient just means the tangent of the angle. So it's the value of tangent of the angle, in degree, or whatever. So when you're looking at, it turns it into a real number that's unitless. So it's interesting. So that means that if you measure your angle in degrees or in radians, you can report the gradient instead, which is just the tangent, the ratio of the vertical to the horizontal. You can report.
Oh,
that.
of the two sides
Yeah.
Interesting.
So
So it's not an angle. It's a ratio.
So instead of saying 30 degrees.
Well, radian's also not an angle. It's a ratio, but radian is not necessarily an angle. It's a ratio that represents an angle.
Well, radians are angles. Yeah, it is a unit of measure for an angle. It is.
Yeah, but it's a ratio.
No, not a radian.
No, the radius.
It's the ratio
It's
of like
the-
2 pi whatever.
A
No, the
radian is
ratio
180
The-
degrees divided by pi.
degrees.
Yeah.
That's-
No.
Yeah, but it's the amount of radiuses that fit
Huh?
in the circumference. Is it the amount of radiuses that fit radii that fit in the circumference?
That's
Or
what you.
radians.
That,
No,
I'm
is
pretty
it?
sure.
That depends on that.
I don't know. What
it's that what you just said is the same number as the number of pi that fit in 180 degrees.
Yeah, but I'm not talking about like the number. I'm just saying what it
But
is.
The
Like,
definition of a radian
No, but the radian
is a slice
itself
of
is
pizza
like-
that is 57.3 degrees big. This
yeah, it's the arc length that is equal to the radius.
a radian is the angle.
Okay. I've always heard the definition is the arc length that is equal to the radius. That's the definition I've always heard.
That's how you find what a radian is.
A radian. A radian is the central angle required to
get that.
intercept an arc that is equal in length to the radius.
Yeah, so it's based on the radius.
It is based on the radius,
But it's the angle
but
that
it's
is
the angle that is formed.
Okay.
But
It's the ratio to the radius.
yeah.
But,
Okay.
but the gradient is reporting not the angle itself, but the tangent of the angle.
Interesting.
That's what I just read.
So why is the gradient of 2 pi 400?
Say again?
Yeah,
David told me that the gradient of 2 pi is 400.
Yeah. It doesn't make a lot of sense.
Why? Because the tangent of 2 pi should be 0. No, shouldn't it be undefined? No. Y over x. Yeah, 0 over 1. Yeah, not 1 over 0. Yeah. Yeah, maybe it's not 400. I'm thinking.